Hello everyone, welcome back. In this session, we are going to discuss about pod. Okay, in Kubernetes, uh, as I explained you that everything is in the form of API. So if I want to create a container in Kubernetes, the minimal resource which I want to create it, I need to create it. That is pod. Okay, so in Kubernetes, pod is an entity which will be holding your container. Okay, so whatever container runtime you are using it, ultimately whenever you want to run a container, that will be is in the form of pod. Okay, yesterday I explained you in the previous session that API version, kind, metadata, and spec. This is the thing you need to write in the EKMS folder. Now API version, this defines Kubernetes API that we need to use in the YAML. Okay, depends on the what kind of resource you want to create it. Metadata, this is identity for the object, like the user want to provide the name, which namespace you want to create it, what labels you want to provide it. All this thing goes under metadata. Spec section, specification for the particular thing. Okay. Now this is exactly the scenario looks like. You will be submitting the request to the master, and from the master, it will be having the API server will take your request, then it will go and check under etcd whether the resource is already there or not. If it's not there, asking the scheduler and schedule your pod inside the worker node. So pod are the smallest deployable unit of Kubernetes computing that you can create and manage in Kubernetes. So basically, whenever someone wants to run a container in Kubernetes, they need to run in the form of pod. A pod is group of one or more container. A pod can hold one container and more than one container with shared storage and network resources and specification for how to run the containers. Currently, the first example which we will discuss it, we will be going to run one pod. Inside that one pod, we will be only running single container. Later on, we will discuss multi-container thing as well. While Kubernetes support container runtime like Docker, we already using it. You have containerd, CRI-O, Docker engine. Many container runtime is there. Pod that runs single container. It's a good practice. One container, one pod. This is the most common Kubernetes case. So you can think of pod is a wrapper around a container. So whenever someone says, I want to run a container in Kubernetes world or Kubernetes environment, it means they mean to say you want to run the pod. Okay, so let's go and see how it looks like. And I will suggest please go and type the YAML file rather than copying and pasting. So you will get the clear picture how the things are working it out. So first of all, the command which have used it, API-resources and grep for pod. Okay, let's see. So this is the pod. The kind is pod. API version is v1. Okay, you can go and use the YAML file. Okay, YAML file, I just run the ram testpod.yaml and I'll give API version colon v1. Then kind will be pod p capital. Then metadata name of the pod. So I'll just say name first pod. Okay, this must be all small letters. Kubernetes RFC says the name of the object or resource must be in the small letters only. Then spec. Under the spec section, what we are creating it containers. Okay. As I mentioned, pod can hold one or more than one container. So it means containers is a list or array. So I'll just say name of the container. Okay. Test container and the image which I want to use it. Image, you can check it out on the hub.docker.com, whatever container image you want to use it. I'll just say Nginx. Latest one. Nginx is a web server container. I'm just using that one. Okay, that's it. I'll just say kubectl. Kubectl is a command line utility. Whenever I want to create any resource or modify any resource, I will be using kubectl with create or apply command. So I'll just say create -f name of the YAML file. I just say testpod.yaml. The moment I do this thing, the pod has been created here. Okay, I just go and see get pods. You'll see there is a pod is creating, container creating is coming here. I just say kubectl describe pod and name of the pod. Okay, first pod. You You see that pod is pulling the image. Point you should observe it here is it describe will give you the event section. The event section is important. Here you see that first scheduler has come. It has assigned the worker node to me. Currently only one server is there. Summit server has been assigned. Now kubelet is coming. As I told initially, kubelet is an agent in Kubernetes which will receive your request. So kubelet has received this request and pulling the image. But here only the one point you should observe it. It is not exactly kubelet who is doing it this thing. It is container D who is doing that thing. Okay, if you go here, scroll up, you see the container runtime is also visible here. One second, I'll just show you. Let's see. Okay, it's started running it. Uh, yeah, here you can see the see container D is the container runtime. So how the flow is working here is similarly like this, somewhat like this. You will be having uh, submitting submitting your request using kubectl command, kubectl create hyphen f command to API server. What API server is doing it? API server first go and check in the etcd whether the resource is already created or not. If it is say that no resource is not created, no resource is not created, API server will go and communicate to the scheduler. Then scheduler will assign. Here you can see scheduler is in the event section. You can say default scheduler has assigned a worker node to me. And then kubelet scheduler assign the node. And then task will be assigned to the kubelet. Task will be assigned to kubelet. Basically, task is what? The pod spec file. Spec file in the sense like which image has to be pulled it up, what is the name of the container, all this thing will be assigned to the kubelet. Now, if you see here in the event section, kubelet is pulling the image, kubelet is pull the image, kubelet has started the container and all this thing. But how kubelet is doing it? Kubelet is using container D to do this thing. So container runtime is the exact thing who is managing the container lifecycle. As I mentioned, container lifecycle where you start the container, create the container, start, run, all this thing is the part of container lifecycle. So basically kubelet is controlling the container runtime now. So this is the command you can use it. You can similarly go and delete the pod. Okay. I can go and delete the pod as well. And this is so sorry, first pod, name of the pod is first pod. So these are the things which you should cover it. You should know it that okay how the pod lifecycle works. And troubleshooting, first level of troubleshooting is always with the describe command. Whenever you run the describe command, go and check the event section. Most of the time under the event section only you will find it out what is the issue is happening here. Okay, so basic first level of troubleshooting is start from the describe command only. Okay, thank you guys for joining this session. In the next session, I will be sharing the lab and providing you the YAML file detail, which you need to type it yourself and perform the activity. Thank you. Thanks for joining this session.